Hello friends, hope you guys having a great day. I'm back with a new tutorial on Ansys Basics, so let's get started. Now before getting into Ansys Workbench and solve certain problems, it is necessary to understand the basics and to know the deep insights of the tool and how it solves the problem that is given to it. So basically what we do is we give the user input to the tool, which is Ansys in our case, and depending upon those user inputs, the tool gets the mathematical model. The implication here is that the tool is not solving the physical problem, but it is solving the mathematical model of the physical problem. And one need to understand here is that what is the mathematical model of the physical problems, what are the physical principles to get the mathematical model from the physical problems, and what are the assumptions involved in the mathematical model. The mathematical model of the problems involves certain governing equations and boundary conditions, and hence these kind of problems are known as boundary value problems. Now when we get our mathematical model, the tool will calculate or obtain a numerical solution depending upon our mathematical model and give us the selected results or selected variables at selected points. Now once we get our selected results at selected points, then by using the post-processing we get our desired results at desired places. These desired results can be displacements, stress, etc. etc. These results involve certain values and some pictures which are important to the problems. Now if we talk about the physical problem, this involves two steps. First is hand calculations. These hand calculations are generally compared with the result obtained after solving the mathematical model using our tool, that is Ansys. Now second is experimental data. Experimental data is also compared with the results obtained after solving the mathematical model, and hence this whole process is known as verification and validation. So this is the simple basic that how Ansys works or how our finite element analysis moves through. Now let us discuss about what are nodes and elements. Basically the nodes and elements are the basic building blocks of our finite element analysis. Now there is a certain steps to perform finite element analysis, and one of which is discretization. So if we assume that this whole box is our domain, so if we discretize this whole domain, we get our nodes and elements. So the corners of this domain are known as nodes, and the regions, that is the orange regions, are known as elements. So basically we can define a node is a coordinate location in a space where we can define the degree of freedoms. Now the results of our finite element analysis, that is the deflections and results, are calculated at nodes. Talking about the stresses cannot be calculated at nodes but are calculated at Gauss points, which can be explained later. Now in real world there are 6 degrees of freedom, as we already know, that is 3 translation in XYZ and 3 rotations in XYZ. Now let's discuss what are elements. So as previously explained, these orange boxes are known as elements, or in other words we can say that an element is a mathematical relation that generally defines how the degree of freedom of a node related to its preceding or the next node. These elements can be lines, areas, or tetrahedrals. Basically these elements defines how the deflection creates stresses within the material. I hope you guys like this video. Give this video a big thumbs up. I'll see you guys next time. Till then, peace out.